Hello everyone. So today we will see what are streams in Java 8. So I have mentioned a few operations over here in README and I will provide this GitHub URL in the description section as well. So in today's session we are going to see what all operations are there in streams which we can do on streams, and in the real-time projects how they have been used. So I've already created this template to save the time. I will just give a small idea, a brief what all things are there. So I have these three types of streams I'm going to create. This is my main.java. In the main.java, this method process chunks I'm going to use to experiment all the operations on the stream. And I've created three types of stream. One is the user stream, second is the employee salary stream, and third is the employee stream which is coming through chunks. So how it is coming from chunks? I'm reading this CSV file which I have downloaded from the kaggle.com, and I'm reading this CSV file through csv.reader, which is already there here in this class. I'm reading this CSV file through this CSV reader into the employees object. I'm passing this object with the chunk size, and I'm breaking this 4000 records into 100 records in each chunk. So 40 chunks will be there. It is more than 4000. I'm just giving an example. Then I'm passing these chunks, 40 chunks of 100 records in each, into this process.chunk. So this will be my third stream. So these three streams I am going to perform, and we are going to perform operations and see what all ways are there to use the stream. So let's start. I'm going to start with the user stream first, and we will see the first operation, map. So we will see what is map and what is flat map, when to use a map and when to use a flat map. So map versus flat map. Before that, just to showcase a small example, how to use a stream. So I'll have a list of string, and I'll get a phone number from this. So stream is users. You can see I've created this users object of list type, stream of, and this is the object of each user, data of each user. So users is a stream. So user dot stream. This is the standard way of calling a stream method. So dot. Now you can see here these are all operations in stream method. So we are going to use map. In this we will call it by method reference. So user type, and I need phone numbers. Dot collectors dot to list. This is my terminal operation. I'll explain what is the difference between a terminal operation and an intermediate operation in a while. So I got this phone number. I'll just sys out the phone which I just got it from the string. Let's build it and run it. So you see I got the list of phone numbers. So I have two users. I got list of both the phone numbers. Now we'll see what is the difference between a map and flat map. So this also, here also we have used a map. Now if you see emails, the email is of type list. Here in the user, the email is of type list. It is not a string or any particular data type. In this case, what will happen if I will use operation map, and what will happen if I use operation flat map? So let's see. If I will have an email and I will put a user type, and I'll get phone number, get email. So this is giving me error because I cannot have a list of string. It is list of string. Now is I will also have it using map, flat map. In flat map, we will not have list of list. We can simply have flat map. instead of method reference, we have to use a lambda expression u dot get email, because we need a stream, because this is a list. This is how we are getting the list of emails. So let's build and let's see what is the output. So you see we got, this is using map and this is using flat map. So I'll just comment out this and I'll just mention it here, using map, and this is using flat map. Now you can see using map, I'm getting a list of the list of the emails of each user, while in the flat map I'm getting a flat data. So in one line, I can get the flat data from the complex data types as well, and then can perform further operations on this, like dot count or get the max or get a filter of any particular domain, like that. So this is, whenever I have a complex data type, list of list or map of map, like that, then I'll be using flat map. While if I have a plain data type, then I will use map. Okay, so we are good for map and flat map. Now we will work on the employee stream and we will use further operations. Now you see here we have an employee salary stream. In this stream, the data is in this format. We have an ID, we have an employee name, we have a department, and we have a salary. Now first operation we are going to see is group by. We'll use a group by and we will find the highest salary grouped by the department. So let's see how we can do that. So we have this employee salary streams. We have to start from the stream only, the same procedure, dot collect. Now what all methods are there? Now in the collect method, we have collectors dot grouping by, and here we will pass employee salary colon get department, because we have to group by department, comma. Here the second one would be collectors dot reducing. In the reducing we will have binary operator, and it will be dot max by, and here, okay, here we need a comparator type of variable. So before this we will create a comparator, because we need to put a, on what field we are going to put a comparator. We have to put a comparator on salary. So compare by salary, compare by salary equal to, we'll have a comparator, not this, dot comparing, and here we will pass in the reference of the method on which we want the comparison. So we will, now we got the compare by salary and we will pass it in the max by. So this is done. So we got this thing. Now we have to define it in a variable. I'll return this in an employee map, and it will be of type map of string, comma, optional of type employee salary, optional of type employee salary. Now we will sys out the statement employee map using reducing group by. We will also okay, let's build this first. Run it. So you can see here we got this QA department, the highest salary employee object, prod department, highest salary object, and dev department, highest salary object. But because this is the employee object, we have to read it. We have to iterate and we have to read it. Before that, let's see one more way how we can do the same group by on the salary group by department highest salary. So I will name this as employee map 1 and sysout I'll do here, in which I will pass employee map 1, and instead of reducing I will use counting. uh, just remove this collectors dot. Okay, so I got this employee salary. Okay, I don't need this optional. I don't need this, the return type. It will be collectors dot collecting, and then in which collecting, and then I'll have collectors dot max by, in which I will pass the same comparator thing. So you see, this is one way of what we are doing in one line now. And instead of null, I will have optional colon get salary stream dot collect group by get department collectors connecting. One more. So these two lines, what these two lines are doing, this one line is doing. The only thing is we are using collecting and then instead of reducing. So now let's print this and let's see what is the difference here. The output will be same. So now you see we got here again the same thing, the same object, employee object, highest salary for prod department and highest salary for this department. So let's iterate it and see. Just read the data. So for map dot entry, map dot entry, in which of type string comma employee salary, and it will be of entry colon employee map 1, I'll read first, dot entry set, and here we will have string employee empid equal to, I'll have the key value here, entry dot key get key, and the other one would be salary, which is of double type salary, and it will give me entry dot get values dot get salary. I'll just sys out the statement employee id colon plus employee I in im empid PID and plus employee salary colon plus salary. So let's print this. So you see, for each department, for the QA department, the highest salary is 6,000. For prod department, the highest salary is 9,000. For dev department, highest salary is 3,000. You can check it out from here. So from dev, these three are dev, highest is 3,000. So for dev, it's 3,000. 3 for QA, out of which 6,000 is highest. So for QA, 6,000 is highest. And for prod, 9,000 is highest. So we got the respectively from this map. The same way we can read this map also, the result will be same. It's just I'm just trying to show you how these operations can be done on using streams. So I'll just comment out this section so that we can move ahead. Okay, so now another operation we are going to see, reduce, how to work on that, and few more things. So I'm going to create a list of integers. I will name it as numbers, and I'll make it a arrays dot as list, and I'll pass here like 3 comma 7 comma 8 comma 1 comma 5 comma 9. So now integer. Now let's see one more. So we, if we have to, for example, we want the sum of this these numbers in each list. So how we will do that? Int sum equal to 0 for int num in numbers. It will do sum plus equal to sum plus equal to num. So now here if I sys out sum, it will give me the sum of this variable. So let's print it once. So you can see we got the sum of all these numbers. Now how we can do this using streams? Now we got these streams because this is a list, so this is a kind of stream. So now using streams, how we can do this? Int sum1 equal to sum1 equal to numbers dot stream dot map to int, and here it will be I lambda I dot sum. So this, then int sum2 numbers dot stream dot reduce 0 comma a comma b lambda a plus b. Int sum3 equal to numbers dot stream dot reduce integer colon sum. This will give me return type optional integer. Another way of getting the same thing is, okay, so Another way of getting this would be numbers dot stream dot reduce. I think this would be max I want. Let's suppose I want here reduce, and I want integer colon max dot get, and I will pass this into integer max value equal to. So let's print all of them. Sys out. We have 4 operations, so I'll just do it sum1 colon plus sum2 plus sum3 plus max value. So I'll just do here sum1 just to differentiate, sum2, sum3, and sum4. And what all we do? See, first one we use map to int, the second one we use reduce by a lambda function, third one we use reduce sum method by reference, and here we are reducing to get the max value. So let's see what it all print. So you can see sum 1 is 33, sum 2 is 33, sum 3 is 33, and sum 4 is 9, which is giving the max value out of it. So reduce is basically used for to get the max function, to get the maximum value depending on what method we are using. So in the reduce we have max method also, we have sum also. The same way you can experiment more. So this is the way reduce will be used. Now we have done all these operations on employee stream. So if you see here in readme, you cannot see, we have this reduce as a terminal operation for each reduce, collect, min, max, count, and filter map. These are all intermediate operations. So what is the difference between intermediate operation and terminal operation is? Intermediate operation is an operation like filter and map which will take input as a stream, perform some operation or logic on that, and then return also a stream. While in the terminal operation, you see, it takes the stream of objects, it performs some operation like max, min, collect, count, sum, and then it returns a particular value instead of the stream. So that's why it is called a terminal operation. Now we are going to experiment a little bit on the CSV file. So let's use this chunks data now. This chunks is a stream on which we are going to see how it is going to how we can use streams to read these chunks. So let me just comment out all these things so that we can only see the new operations. Okay, so now chunks dot for each chunk this out. We will just print the processing chunks. I'm putting a header kind of thing so that we can differentiate between the chunks. So this will read each chunk. For each will read each chunk. So each chunk has 100 records in it. So list of string. Now in my I'm going to have this employee CSV in which the data is in this format, in like education, joining year, city, uh, payment year, age, gender, ever benched. So this is the data which I got from the Kaggle. So I'm just using it as it is. I have not changed anything. So this is kind of a raw data. Now in my main.java, when I'm reading this, I will have this list of string and I want the joining year. So joining year chunk dot stream dot map, and here I'll have employee and reference and year get joining year, and I want dot collectors dot to list. And I will just print here dot for each system dot out reference by println. So let's see what it printed. Semicolon. So let me just build it first. This is one of the way to print the statement. So let me just run it. You see, I got this data processing chunks. So you see, each chunk will return me the year, joining year, whatever joining year is there. Now what I want is I want to sort this. So what I will do, I will just do get joining year dot sorted dot collect. Sorted would be a method. So this will return me sorted. Earlier this is not sorted, but now this will sort it. So see, now this data is coming for each chunk, it is sorted. Now if you see, this is the previous one and this is the new one. So whatever operations I am doing on the stream, it is on one chunk. So one chunk is one stream because I am chunks dot for each. I have a list of chunks of chunk. So this operation is happening only on one particular chunk. That is how this stream is mapped. Now another operation, let's filter the data. So how will I filter the data? Another operation is filtering. So let me just do again chunks dot for each, and in for each I'll have chunk lambda function chunk dot stream dot stream dot filter, and in the filter I want employee lambda function employee dot get joining year, and the get joining year dot equals, and in the equals I want all 2014 years, and dot no need for sorted dot collect vectors dot to list. Vector for each employee dot get joining year dot equals dot 2014 dot sorted dot collect this for each. I will print it system dot out and print ln. So done. So let me print this. I'll comment this out. So now from each chunk I will just filter that. I've filtered the data only for 2014 year. So you see I got all the data but only for 2014 from each chunk. So this is how we can perform the operations. Okay, one more small operation we can try. We can count like how many records are there in each chunk. So control this. I'll do chunks dot for each, and in this again chunk dot stream and chunk dot stream dot count. This one I'll just sys out here and then print number of chunks. Actually I'll just copy this chunk dot count and I can pass it here. So this will give me the number of chunks we have. Put it in this chunk dot this count and then this, and I need to close this, right? So chunk and this will come inside this, and then it will be closed, and this and this and this. Okay, some error has come here. What is the error? Why is it this error? Okay, so this is okay. I'll remove this. Some extra parenthesis has come because of which this issue is coming. Okay, practice. Yeah, so this is fine. Now after this, if I want to use this piece of code, then I want to comment this one out. I just want to show how this count thing works. It should give me the number of chunks of count. Yeah, so see, I got 100. It is giving me count in each chunk. So last one has 43. Each chunk has 43 counts. So this is how we can use these operations. We have to follow the syntax of the streams, and we can just use and experiment the operations by here tweaking here and there some of the things. So I hope this session is helpful to understand what are the streams. There is a lot of scope because I just tried this experiment that reading the data set from the Kaggle and how we can use streams on that. We can also do the same thing on the data, fetching it from the database, how it works in that case. So when the data is huge, how streams are helpful. We also have parallel streams and instead of stream which runs on a multi-threaded environment. uh, so if you have any queries or any use case which you want to perform with the streams, um, please feel free to uh, give the use case or discussion or in the comment section. I will definitely consider that and work on it. Thank you so much. I will provide the GitHub URL in the description section. Thanks.